Imagine a world blisteringly close to our sun. A place where daylight temperatures can soar high enough to melt lead, reaching a staggering 430 degrees Celsius. You would naturally assume this world is a scorched, barren wasteland, the last place in the solar system you'd expect to find ice. Yet, Mercury, the innermost planet, guards a truly astonishing secret in its darkest corners. Within the permanent shadows of craters near its poles, where the sun's rays have not reached for billions of years, we have found water. Not just a few molecules, but vast deposits of water ice, preserved in a cosmic freezer just a stone's throw from a stellar furnace. This paradox is what makes the study of our universe so endlessly fascinating. So, while the planet's equator is unimaginably hot, its poles are unimaginably cold. Mercury has almost no axial tilt. Unlike Earth, which is tilted on its axis by about 23.5 degrees, giving us our seasons, Mercury spins nearly perfectly upright. Time itself behaves differently on Mercury. It is a world where our fundamental understanding of days and years is completely turned on its head. Here on Earth, our day is defined by one rotation on our axis, and our year is one orbit around the sun. On Mercury, they are strangely, wonderfully intertwined. This peculiar relationship between its orbit and its rotation is known as a 3-to-2 spin-orbit resonance. Imagine standing on Mercury's surface. You would watch the sun rise, but it would move across the sky with agonizing slowness. It would take 88 Earth days for it to reach its highest point, and then another 88 days for it to finally set. If you were standing in the right place on the surface, you would witness the sun briefly halt in the sky, move backwards for a short time, and then resume its slow forward march. Mercury is, quite simply, a shrinking planet. As its massive iron core has slowly cooled over the 4.5 billion years since its formation, it has contracted. This cooling and contracting of its interior has caused its rocky crust to buckle and break, creating enormous cliffs and scarps that crisscross its surface. The planet is literally getting smaller over time. Some of these cliffs are hundreds of miles long and can be over a mile high, towering over the surrounding plains. By studying the size and distribution of these scarps, scientists have been able to calculate just how much Mercury has shrunk. This process of planetary contraction provides a window into the thermal history of a world. It tells us about the immense heat that was present in Mercury's core in its youth, and how that heat has been radiated away into space over eons. When we look at Mercury's wrinkled face, we are seeing the story of its life. These vast planet-girdling scars are the evidence of that immense slow-motion geological stress. When we think of an atmosphere, we might picture the thick, cloudy blanket of Venus or the rich nitrogen-oxygen mix of our own world. Mercury has nothing of the sort. To say it has a thin atmosphere would be a colossal understatement. It possesses what scientists call a surface-bound exosphere. This is a collection of atoms that are blasted from the surface by solar radiation and micrometeoroid impacts. They are not bound together as a gas in the way we understand it. Instead, they follow individual ballistic trajectories, soaring high above the surface before eventually falling back down. This exosphere even forms a long, glowing tail, much like a comet, as the solar wind pushes these atoms away from the planet. This tail of sodium atoms stretches for millions of kilometers through space. At first glance, Mercury might seem like a smaller sibling to our own moon, but that comparison is only skin deep. If you could peel back its crust, you'd find something truly extraordinary. Mercury has a metallic core that is disproportionately, astonishingly large. Current models suggest that this iron-nickel core makes up about 85% of the planet's radius. Mercury is, in essence, a giant ball of metal with a relatively thin rocky coating. This composition makes Mercury the second densest planet in the solar system, bested only by Earth. Data from the Messenger spacecraft confirmed what scientists had long suspected. Mercury has a magnetic field. It's weak, only about 1% the strength of Earth's, but its existence implies that at least part of that giant iron core is molten and churning. This means that deep within this tiny, shrinking planet, a liquid iron ocean is still sloshing around, generating a protective magnetic bubble. Mercury's iron heart is still beating, a faint but persistent magnetic pulse that tells us the planet is far from a dead rock. It is a dynamic and complex world, with a dramatic past and a surprisingly active present. Our relationship with Mercury is as old as civilization itself. It's one of the 5 classical planets that's visible to the naked eye, a wandering star that's traced its path across the heavens in the myths and records of countless cultures. The Sumerians, way back in the 3rd millennium BCE, were among the first to record its movements. associating it with their god of writing, Nabu. The ancient Babylonians, who were meticulous astronomers, charted its comings and goings with remarkable precision. They knew it as the jumping planet because of its swift journey across the sky. The ancient Greeks at first believed these were two separate objects. They called the morning star Apollo, after the god of the sun, and the evening star Hermes, the swift messenger of the gods. It was Pythagoras, in the 5th century BCE, who is often credited with being one of the first to propose that Apollo and Hermes were, in fact, one and the same celestial body. The Romans inherited this understanding, naming the planet Mercury after their own fleet-footed messenger god. The name stuck, a tribute to the planet's rapid orbit. Even with the invention of the telescope in the 17th century, it was notoriously difficult to observe. Galileo Galilei was one of the first to turn a telescope towards it, but his instrument just wasn't powerful enough to resolve any surface features. It wasn't until the 19th century that astronomers like Giovanni Schiaparelli began to create the first rudimentary maps of Mercury. Peering through his telescope during those rare moments of clear viewing, he sketched faint dark patches that he believed were permanent features. Based on his observations, he incorrectly concluded that Mercury was tidally locked to the sun, always showing the same face, just as the moon does to Earth. While his conclusion was wrong, his patient, painstaking work laid the foundation for all future studies. For millennia, Mercury was a world known only through the faint glimmer of reflected sunlight. That all changed on the 29th of March, 1974. On that day, a small robotic explorer named Mariner 10 swept past the planet, becoming the first spacecraft ever to visit the innermost world. It was a mission of incredible audacity. To get there, Mariner 10 had to perform the first ever gravity assist maneuver, using the pull of Venus to bend its trajectory and slow it down enough to reach Mercury's orbit. The images it sent back from Mercury were a revelation. They showed a surface that was shockingly similar to our moon, ancient, gray, and heavily pockmarked with craters of all sizes. Among the craters, it revealed those enormous cliffs, the lobate scarps, which were the first clues that the planet might be shrinking. It also made the completely unexpected discovery that Mercury possessed a magnetic field. This finding baffled scientists at the time since it was widely believed that a small planet like Mercury should have cooled and solidified long ago. The spacecraft made a total of 3 flybys of Mercury between 1974 and 1975. During these brief encounters, it managed to map about 45% of the planet's surface. After its third and final flyby, Mariner 10 ran out of the nitrogen gas it used for attitude control. Its mission came to an end, and it is now silent, drifting in its own orbit around the sun, a ghost ship in the inner solar system. But its legacy is monumental. It gave humanity its first close-up look at this enigmatic world, providing the foundational data that would drive Mercury research for the next 3 decades. For more than 30 years after Mariner 10, Mercury remained largely unexplored. But in 2004, NASA launched a mission designed to meet this challenge head-on: the Mercury surface, space environment, geochemistry, and ranging spacecraft, or MESSENGER. Its goal was not just to fly by, but to do something far more difficult: to become the first spacecraft to orbit Mercury. The journey was a masterpiece of orbital mechanics, a 7-year-long cosmic voyage. Finally, on March 18, 2011, MESSENGER fired its main thruster and gracefully slipped into orbit around the Sun's smallest planet. Over the next 4 years, MESSENGER transformed our understanding of the planet. It mapped the entire surface in stunning high-resolution detail, revealing the hemisphere that Mariner 10 had missed. Its suite of advanced instruments peered beneath the crust, confirmed the existence of a liquid outer core, and precisely measured the planet's gravitational field. And most remarkably, its instruments peered into those permanently shadowed polar craters and returned the definitive evidence for vast quantities of water ice. After exhausting its fuel, the mission ended on April 30, 2015, in the only way it could. Guided by its controllers on Earth, MESSENGER made a final, deliberate descent, crashing into the planet it had studied for so long. It now rests on the surface, a tiny, man-made crater among the countless natural ones, its work complete. It was a fitting end for a craft that became one with the world it was sent to explore. Mercury remains a world of profound mystery. Each mission, from the ancient Skywatchers to the robotic explorers Mariner 10 and MESSENGER, has peeled back a layer of the unknown. only to reveal deeper, more fascinating questions beneath. We now know of its icy poles, its shrinking crust, its giant iron heart, and its ghostly atmosphere. But we still don't fully understand how a world so small and so close to the sun formed in this peculiar way. Why is it so dense? What is the precise mechanism that keeps its core molten and its magnetic field alive? What other secrets are locked away in those shadowed craters? The quest to answer these questions continues. A new international mission, Bepi Colombo, a joint venture between the European Space Agency and the Japan Aerospace Exploration Agency, is already on its long journey to Mercury. It's a dual spacecraft mission, carrying an even more advanced set of instruments than Messenger. When it arrives in orbit in late 2025, it'll begin a new era of Mercurian exploration. The story of Mercury is a perfect reflection of the story of science itself. It's a journey from myth to measurement, from a point of light in the sky to a complex physical world. It teaches us that the universe is not always as it seems, and that our assumptions are meant to be challenged. The drive to understand this small, swift planet is part of our innate human drive to explore, to push the boundaries of our knowledge. As we stand here on Earth, looking out into the vastness of space, we're part of an unbroken chain of inquiry that stretches back to the first humans who looked up and wondered. Mercury, the swift messenger, continues to beckon. It reminds us that there are always new frontiers to cross, new mysteries to solve, and that the most exciting discoveries are often the ones that await us just beyond the edge of what we thought was possible. The journey is far from over. It has only just begun.